Hello everybody, welcome to the Python course. In this Python course, let me give you the course outline, what we were going to study, what are the topics we gonna cover in this Python programming course, right? So let me guide you step by step into the various modules that we have that we will be looking at. The first module is Introduction to Python and Installation. This is the basic module in which we would be start working with our Python and we would understand why Python is so important. We also learn about what is the use of IDE, that is the integrated development environment, how we can work with our Python language in this integrated development environment. Then we will see what is Anaconda, how we can install Anaconda on our Windows system, on our Linux system or Mac OS system, right? So this is the basic introductory class in which we will cover the prerequisite, right? And if any intended student doesn't know anything about the Python, so this class is for them also, because I will guide you step by step how we can proceed with the Python language. If you don't have any prior knowledge to Python and don't know how to code in programming, we will give you step by step instruction how you can proceed with your Python language, right? Then we will start working with our Jupyter notebooks. In this course we have chosen our IDE to be Jupyter notebook because Jupyter notebook is gaining popularity these days, and on the industry also it is widely used. Whether you wanted to do your data science or you wanted to do your machine learning projects, Jupyter notebooks are well used. So in the next module we will cover the Python data types and variables. Here a basic introduction to how to start working with your Jupyter notebook. Then we'll understand what is a variable, what is a data type, how we can convert one variable into another data type or vice versa, that is typecasting. We will also see what is the print statement, how we can write inside our print statement, and input function, how we can take the user defined values and work with that, right? So this is the module which is based on your data types and variables. Then third module is your operators and your control statements, where we will learn about the operators and the operand, your assignment operator, arithmetic operator, logical operator, relation operator, right, comparison operator. So these are the various kinds of operators you would be needing in your programming, right? So to understand the logic better, then we'll work with the control statements, that is if else statements, nested if else, for loops, while loops, break statement, continue, pass, right? Okay. Then the fourth module is our list and tuples. So we'll see what is list, how list is different from an array, creation of a list, list indexing, list slicing. Then we'll see various kinds of list operations that Python itself has given us, how we can compare the list operations with the stack operations, nested lists, list as a mutable, whether list is a mutable or immutable, shallow copying, deep copying, right? So these are the various topics which are included under list part. Then we'll see tuple creation, unpacking of tuple, packing of tuple, tuple operations, that is string, slicing, string length concatenation and slicing. Then what is the basic difference between your list and tuples, right? Can we convert list into tuples or vice versa, right? Then the next module is our string manipulations. We will learn about what is string, right? So is there char or string similar? We have if we are familiar with our C++, we have the data type as char. So we will understand how char is different and strings are different, or maybe they could be same also, right? So this lecture is all about your strings. Anything which comes under course is your strings. How to access your strings, how to index the strings, string slicing, string concatenation. Then we have the basic string methods, right? These are the inbuilt methods which are provided by the Python. Then we'll see why strings are immutable. Then split and join methods we'll see in this module, right? So then next module is our dictionaries and sets. We'll cover what is a dictionary, how we can create a dictionary, how we can access a dictionary. Then dictionaries keys, as numbers we can use, as strings we can use, as tuples we can use, right? And what kind of data type does the dictionary key holds. There are various dictionary methods also, dot keys, dot values, dot items, right? So these we'll see. Also we'll see set creations, set operations and modify sets, some kind of union operations we can do in case of sets, and this yields a faster operation, right? After that we move to the functional programming part. So here we'll cover the basic structure of how we can create a function. Then what is the need of creating a function, right? So what advantages do we have when we create a function? Then we'll see how we can define a function, what is its prototype, how we can call a function, what are the parameters that needs to be passed in a function, what types of functions it takes, what type of functional arguments it have, global scope, local scope, variables, returning values, right? So these all we'll see in the functional programming part. Then we have the OOPS programming. Here we'll deal with the classes and the objects. We'll see about the class methods, class variables, static methods, instance variables, init method, right? Then we have the lambda function, filter, map, reduce. So these all will be covered in your OOPS programming, right? Then the next part is your file handling and modules. So this module is also very important in terms of your file read write operations. You have a file and you wanted to read the contents of the file, modify that, append that, right? So there are various file methods and file modes, and in the later part of this section we'll study about the modules, what kind of modules are used in Python, the import statement, how import statement works, the math library, the OS library, the system path, the random. So these all modules will handle. Then exceptions, right? If you encounter some kind of error, how to handle that error, what practice we'll use to write the exception handling part, right? What kind of syntax is there, and what is the difference between your try, accept and finally block, right? Or how we can write the user defined exceptions, right? Also we'll look upon the regular expressions, right? So this also includes your RE module, and we'll see how we can create the regular expressions and use it in our programs. Then up till module 10, all the basic Python functionality including your functions, data types, variables, controls, file handling part has been covered. Now we'll be moving to your data science part, that is your NumPy, Pandas and Matplotlib. So these are some of the libraries which you will be working with, and this NumPy library is fastest than your list. If you want to do some kind of computations using your list, right? So list, doing your computations in list as compared to your NumPy is faster. So why it is faster, we will see it, how it is faster. We will practically analyze this by taking a operation or a arithmetic operation, and then we'll look upon it, right? So here we'll see how we can generate different kinds of arrays using numpy array, then using your inbuilt methods also, and performing various kinds of operations on your arrays and manipulate them. We'll see index slicing, iterating, modifying the arrays, and some mathematical and statistical methods that we'll cover on this topic. Then we'll see introduction to our pandas. Here we will deal with our series and data frame objects, arithmetic operations on series and data frame, importing and exporting your data, right? Dealing with your missing values, NA values, okay, right? So we'll see various kinds of operations where data is being contained in your pandas data frame object, and then you can cleanse your data. You can try to clean your data and come up with a structured one, right? Structure analysis of the data can be also be done in terms of your by using this pandas library, right? That is known as exploratory data analysis. Then for the visualization we have two libraries, that is matplotlib and seaborn. So these help us understanding the relationship between two variables, whether you make a box plot, scatter plot, histograms, right? So these are some kinds of libraries which yield us the better visualization, right? So we'll also look upon these libraries. And also seaborn is a high level library which gives you a better visualization, or you can see better graphical representation of your data. Then in the module 14 we'll cover how we can make a connection string between our databases and can fetch records, pull records from your data into your Python, right? This will also see here how we can convert your MySQL data to your pandas data frame object, right? And module 15 is your advanced Python module in which there's a basic introduction to OpenCV library, and we will start working with your images. Here we'll process the images and then save the images, and we'll see the basic structure of an image, right? That also includes your numpy arrays, right? Then in the module 16 we'll give a project based on your Python, and the students has to complete a real life project based on Python where they are expected to implement all the concepts learned during this Python course. Okay, so let's start with our first module, that is introduction to Python and installation, right? Okay, so here in this lecture we'll see what is data science, what are the tools required for data science, and history of Python and Python IDEs. So as we all know that we live in a world that is drowning in data, and data is being generated from various sources, whether you take a website, whether you take a smartphone, whether you take a e-commerce, right? So each and every entity is generating huge volumes of data every day, and it is being generated continuously, right? So your smartphone is building up a record of your location, and sensor is also taking a real-time information that goes into your servers, onto your cloud, and gets multiplied every second, right? And also e-commerce commerce websites collect purchasing habits of their customers, and onto that data you come up with the inference or come up with the prediction that what is the buying capacity of the customer. Then what is data science? Data science is the interdisciplinary field that brings together the computer science, statistics, and mathematics to extract useful insights from your data, right? So as I already given you example that e-commerce websites take your data, and on the basis of that they suggest customers what to buy next, right? So if we are trying to buy butter, so it is likely that they will also recommend that you try out milk bread also, right? So because bread works with the butter best in most of the cases, so generally, so this is a field that required some kind of statistics and mathematics which are applied to your data part, and then it comes with better business decisions. Also, I am a grocery store owner and I wanted to make predictions of my next purchases in the coming weeks, so I need to analyze my data and come with the prediction so that I could procure the items at early as I possible and with the low cost, right? So the popular tools used in data science are Python, R, Microsoft Excel, SAS and SPSS. So these are some of the pre-processing and analysis tools. So Python has widely used, gained very importance in the data pre-processing because of its open source and free available data science libraries. So rest of the tools have some limitation because they cannot handle complex data, and also some of the tools are licensed and they charge very heavy huge amount, right? So some of the data exploration and visualization tools such as Tableau, ClickView and Microsoft Excel, so these are also paid tools. So in place of these tools, some kind of free and open source available libraries has been included in Python, that is Matplotlib, Seaborn, and you have Plotly, ggplots, so which can does the data exploration and visualization, which tells the story to your end customers. So we have the parallel and distributing computing. In case of your big data, we have some kind of frameworks such as Apache Spark and Apache Hadoop, so which does the distributed computing for us, and they also have the compatibility with this available frameworks. Then we study about the evolution of Python. The Python was developed by Gaudio van Rossum in the late 80s at the National Research Institute for Mathematics and Computer Science at Netherlands. So far, so many editions have evolved so far. So for the Python, current version is 3.8 and the stable version is 3.7, right? And the oldest version is 2.7, right? So generally it is being recommended that you either use Python 2.7 or Python 3.7 because these are both are the stable version. So rest, you it is not said that you cannot use it, you can use it, but while calling other libraries or while working with the other libraries, it might give you some kind of error or some kind of compatibility issues might come, right? Because on the official website they have not given the uh, tag of stable version there, right? So those stable versions they have given as Python 3.7 and Python 2.7, right? What are the advantages of using Python? Python has several features that make it well suited for data science. It is open source community development, and it is developed under open source initiative approved license, making it free to use and even distribute commercially. Syntax is very simple and easy to understand, and libraries which are specifically designed for data science, and it combines well with the majority of the cloud platforms such as AWS, Microsoft Azure, Google Cloud, right? And it is very uh, gaining very high popularity in these areas of artificial intelligence, machine learning, deep learning, right? Because of the compatibility issues, right? Right. So it has got huge compatibility with your cloud services, or you can say your big data frameworks, right? And also with the help of with the computer vision also, so you can do various tasks. Then we'll come up with the integrated development environment. So what is integrated development environment? So Python is a language just like English is your language. It is a language in which computers can understand it, and then it is uh, such that it is desired to do some kind of operation or task, right? So for communication you use some kind of a cardboard or a piece of paper to communicate in terms of your English language, right? So that it could be understood by others. So in here also Python is a language, so it needs some kind of a software development kit or a software tool which can does the simplification process, which is used to design or designed to simplify the software development process, right? So it could have some kind of a utilities provided for managing the tool, for compiling, for deploying and for debugging the software, right? So that it could interact with your hardware and gives us the efficient results, and also ease the programmers, right? In case of errors they could tell us syntax or error highlighting part, right? They could tell us the code completion. So these are some of the utilities which has been inbuilt in your IDEs, and they could give us a huge like they could give us the ease, right, of writing the software, right? So these are they basically follow the three centralized key tools that form the crust of software development, that is source code editor, compiler and debugger. So all the things are inbuilt in your IDEs. We have the source code editor also, we have the compiler also, which compiles your code from source code to your byte code, and then that is being machine readable or machine interpretable, right? And debugger is used for debugging your code to find out the errors and fixing them, right? And additional features which include syntax and error highlighting, code completion and version control. So these are some of the additional features which you can work with and which can help you in writing your code very efficiently. So now we'll talk about what are the commonly used IDs. So IDs are available, freely available in the market, and you can choose any one of these. So the commonly used are Spider, PyCharm, Jupyter Notebook, Visual Studio Code, and lot many others are also there, right? So let's understand one by one what is Spider, what is PyCharm, what is Jupyter, and what is Visual Studio Code. So Spider is supported across all the platforms, and it is bundled with Anaconda, which comes along with all the Python libraries. So this Anaconda distribution, so what is that? So we'll be covering in a few minutes later. Let just stick with me, right? So for the time being, just understand it is a IDE which is supported across all the platforms, and it is available as open source, and it is developed for Python and specifically data science, right? The interface looks something like this. Here in this part we can write our code, and here in this part is the console. Here we can see the output. We have the variable explorer in which we can see the variables and the values and the type, right? So the features, it is robust in its syntax is robust, and it gives us the error highlighting part, code completion, navigation, debugger. So these are all the features which we already discussed that is present in any of the IDs, and it is interface is similar to MATLAB and RStudio, right? If you are familiar with your MATLAB and RStudio, so it would look something similar to these tools also. Then we have the PyCharm, so that is also supported across all the platforms, Linux, Mac OS and Windows. They are available in two versions. One is the free and open source, and another one is the professional paid one. So it is not that you cannot work with your free and open source version. You can write your programs, you can write your Python code, but it is only limited to your Python and supports only Python, right? So it is also bundled with Anaconda distribution and can be installed separately too, right? So interface looks something like this. Here we have the editor in which we could write your code, and here in the bottom we could have Python console where to see the output, right? Here we have the directory structure, right? Then the features include code editor, syntax error highlighting, code completion, navigation, unit testing, debugger, version control. So all these features are available across all the IDEs, right? Then we come across Jupyter Notebook. So it's a web application. It's a client server model, first of all, right? So that allows creation and manipulation of notebook documents called notebook, and it is supported across all the platforms and open source, right? So interface looks something like this, and here we have the cells in which we will be working with the cells, and here we could write our code and then visualize the code there and there itself only, right? So it can be also used remotely, right? So we can type the local address, we type the remote address, and then we could start working with our Jupyter notebooks, right? So it is bundled with Anaconda and can be installed separately. It supports not only Python but Julia, R and Scala also, and it consists of ordered collection of input and output cells that contain code, text and plots, right? So this is also very interactive way of writing your code, and if you wanted to show it to someone or show the working of your code to someone, so that is really very effective, right? So in this course we will be talking about or working on the Jupyter notebooks primarily, right? So we can share the code and narrative text through output formats like PDF, HTML, etc. For the education and presentation tool also it is very helpful, and it also has most of the good features of IDE, right? Then we have the Visual Studio Code, so that is also supported across all the platforms. It supports Python, PHP, Java, and it is also well suited for developers. It also has your code completion, navigation, error highlighting, syntax, robo syntax, etc. Right? So interface looks something like this. So we could write our code, and here we have the directory structure. At the bottom we could right display the output. Right? Now the question arises how we can choose the best ID. So it all depends upon the requirements first of all, and working with different IDs help us understand the our own requirements. Second thing, also if you are working with your data science and your Python and your project, so I would recommend you could use your Spider and your Jupyter notebooks because it is being widely used. And if you are going for a full-fledged web application, then go for your PyCharm. Right? It is not that you cannot code it in your Jupyter notebooks or Spider, so you can do it because almost all the IDs have a similar structure and similar features are included in your ID. So if you are familiar with one of the IDs, so you can easily switch to another ID. So that's not a big issue or a big deal, right? So you can easily switch and flow to or back and flow to all these IDs, whichever way you feel, right? Okay. So now we have covered the popular tools that are used in data science, evolution of Python, and discussed about the integrated development environment, right? Okay. So in this next part, we will be start working with our Anaconda, and also I will tell you how we can install your Anaconda toolkit, right? And your Jupyter notebooks, right? So till now, right? Uh, Thank you guys. Thanks for watching. So we'll meet in the next video.